first question that I want to go over was number 10 from the 6.2 bookwork. So that had the region bounded by y equals e to the negative x, y equals 1, and x equals 2. And we want to rotate that about y equals 2. So the first step, of course, is to draw this thing. So y equals e to the negative x is going to go through the point 0, 1, and we're going down because it's e to the negative x. And then we have y equals 1, which is just this line right here. And then we have x equals 2. So that's this line right here. So what is bounded by all three of those lines? That would be this region right here. So that's what we're revolving around right here, our line y equals 2. So now I'm clearly going to have a radius outer and a radius inner. So again, you go from the line that you're rotating about to the curve. So that's the longer one. And this is the shorter one, right? So our radius outer is going to be, we're drawing from top to bottom. That's 2 minus the curve, e to the negative x. That's going to be our radius outer. Our radius inner is simply 2 minus, this is just y equals 1. So our radius inner is just 2 minus 1, which is 1. So that's nice and easy there. So now, to find the volume, well, we're going to be rotating, so our cross-sections are circles. So we have our pi radius outer squared minus radius inner squared, right? So I'm going to just factor that pi out. What are my bounds? I'm doing dx slices, so I'm going from here to here. So from 0 to 2, radius outer squared, 2 minus e to the negative x squared, minus the radius inner, which is just 1 squared, dx. Okay, so now I am going to just simplify as much as possible, so I'll FOIL that out. I have 4 minus 2e to the negative x plus e to the negative x times e to the negative x, same base as add the exponents, so I have e to the negative 2x minus 1 dx equals pi. Then I have 4 minus 1, which is 3, minus 2e to the negative x plus e to the negative 2x, right? And so now I need to take the antiderivative. So I have pi, the antiderivative of 3 is 3x. And oops, I made a mistake because I had minus 2e to the negative x, so this should have been a 4. I have 2 of them, right? There we go, that's better. Minus, what's the antiderivative of 4e to the negative x? Well, think about if I took the derivative of e to the negative x, wouldn't I need a chain rule to apply? So when I'm taking the antiderivative of e to the negative x, I need a u sub. Again, if I were to take its derivative, I wouldn't have needed a chain rule. So now I'm undoing that. I need a u sub. So the u is just going to be that negative x, and the du is going to be negative dx. I don't see a negative dx in my problem, so I'm going to change it to negative du. I'm going to replace with my dx. So now I have the integral of e to the u times negative du. Pull that negative out. The antiderivative of e to the u is just e to the u. So now that I figured that out on the side here, I'm going to go ahead and just plug that in. So I have minus 4. Let that hang out. And then the antiderivative of e to the negative x was negative e to the u. So negative e, and then my u was negative x. Right? There we go. Plus, now I need to figure out what the antiderivative of e to the negative 2x is. So let's do the same thing. E to the negative 2x dx. And so the antiderivative, u is going to be that negative 2x. du is going to be negative 2 dx. But do I see a negative 2 dx there? No, I don't. So divide both sides by negative 2. So I have negative 1/2 du is equal to dx. I'm going to replace my dx. E to the u times negative 1/2 du. Pull that negative 1/2 out. And again, the antiderivative of e to the u is just e to the u. So I have negative 1/2 e to the u plus c. And then I can go back to my problem and replace that with negative 1/2 e to the u, which was the negative 2x. And I'm evaluating that between 0 and 2. Great. So now I can just plug those numbers in. So I have pi, let me just simplify this a little bit, 3x plus 4e to the negative x minus 1/2 e to the negative 2x. That looks a little bit cleaner and nicer. Now, don't forget, I need to plug in the 2 and I need to plug in the 0. And this is really important to plug in the 0 because I have e's and e to the 0 is actually 1. It doesn't just cross out, so don't forget that. So we have 3 times 2 is 6 plus 4e to the negative 2 minus 1/2 e to the negative 4. And then we have to subtract out, put in 0. So 3 times 0 is 0. Plus 4e to the 0 is 4, minus 1/2 e to the 0 is minus 1/2. So I have pi, then I have 6 minus 4 plus 1/2, which is 2.5 or 5/2, plus 4e to the negative 2 minus 1/2 e to the negative 4. And that is my answer. The next problem that I wanted to do was that extra example, and that was with the pyramid, and it said that it had a height of 20 and its base was 20. And so the easiest way I think to draw that is to just flip it on its side, kind of like that. And we know this length was the 20 centimeters, and then this length here was also 20. So, you know, if you went up 10 and down 10, then that's just flat on your axis, and I think it's pretty easy to visualize that way. And then the cross sections are going to be squares because it's a pyramid with a square base. So I need to think about what my cross section is, what this height is. So what is this curve here? Well, I know that it's just a line, right? That has a slope of down 10 over 20, negative 1/2 x, and the y-intercept is plus 10. And then this line right here, you could either think of, you know, it's reflecting over the axis, or you could just think about it up 10 over 20. So that's just 1/2 x minus 10. So this side here is top minus bottom, right? So minus 1/2 x plus 10 minus 1/2 x minus 10, which is negative 1/2 x plus 10 minus 1/2 x plus 10, which is minus 1/2, and minus 1/2 is minus a whole, plus 20. So each side length is going to be minus x plus 20, meaning the area of that square is negative x plus 20 squared, because it's a square. And I'm just going to simplify that by foiling x squared minus 40x plus 400. So now to find the volume, I'm going to be adding up from 0 to 20 because I'm doing dx slices. So from 0 to 20, and then the area was just x squared minus 40x plus 400. Take the antiderivative, and I have 1/3 x cubed minus 20x squared plus 400x, evaluated between 0 and 20. So now if I put the 20 in, I have 20 cubed is 8,000 thirds minus 20 times 20 squared plus 400 times 20. And then, of course, if I put in 0, I just get a 0, so that's nice. And then look at this. I have minus 20 times 400 plus 20 times 400. So those cross out, and I'm just left with 8,000 thirds as my final answer. And that's how I do that one.